Okay, so let's move ahead for the another method. And let's say we will just do it using mean depth method. This is going to be the concept. We will be using the same table such as stations, NSL, formation level. Okay, and the previous you can say table, the depths were just known. Here, as you can see, depths are not known. However, the NSL and let's say the formation level is known. If the depths are known at each station, you don't actually need to add these things in the table. Okay, just add the depth. Very simple. Okay, and over here, as you can see, the depth can be actually, if you subtract any cell from the formation level, that's your depth actually. Now, and if the formation level is just a bound, let's say this is the NSL, okay, here, and this is the formation level. It means it is just filling, you can see it. However, if the NSL, let's say this is NSL, and let's say over here we have the formation level, this one, then of course it is just cutting. This should be cutting, and over here this should be filling. So it's very straightforward. And then we should have depths, and of course just NSL minus formation level, or maybe formation level minus NSL. Okay, you can just switch their location, does not matter. So these should be the depths, and remember this method is known by the mean depth method. So we will add two depths and then divide that by 2, so we can have the mean depth. Then of course areas, maybe the central area like BD and SD square for both sides. Okay, if the slope for both sides, okay, I mean you can say side slope are different, then of course you can add another column over here, and we will have SD square divided by 2 for one side and SD square divided by 2 for another side. Okay, and then as you can see, we should have the total area, and then of course area times interval can be actually the quantity, which should be the cutting or maybe the filling. Is that clear? Okay, let's just have an example so you guys can understand better. In the same example, we are asked to work out the quantity of earthwork for a portion of road. We have a road whose formation weight is just 10 meters, the same thing. But here, the things are very different. The side slopes are 1 and 1 in cutting, okay? When there is cutting, we will use 1:1 side slope. However, when there is filling, we'll use 1:2 as the side slope. The natural surface level and formation levels at different stations are given below. Okay, again my pin is not working. Okay, it's working now. Okay, so we have stations such as 0, 30, 60, 90, 120 and 150, and then NSLs. Okay, these NSL must be provided by the surveyor. Okay, at each station, you can say, let's say this is maybe road portion, and the road has just started from 0, then we have 30, okay, then we have 60, 90, 120, and let's say there is, let's say, curvature, no problem, and then we have 150. Okay, so NSL at this station, at 0 station, that is just determined at 30, at 60, at each station, and they are just noted over here. Then we have the formation level, which is just the work of designer. Like maybe if you just draw the profile of the same road, the formation level is just drawn, and then the maybe the road surfacing or maybe the road topping is just leveled with that formation level. Okay, and then we decide the cut and fill based on the formation level. Now, as you can see, the formation level is just above. The value of the formation level is just more than the NSL. It means here we should have filling. Okay, again, the formation level, it is just more than the NSL. It means filling again. The formation level for station 60, it is more than the NSL. It means filling again. Okay, here the formation level for station 90 is also more than the NSL. It means filling again. However, look at the station 120. The formation level is just, you can say, less than the NSL. It means there should be cutting. And again, at 150 station, the formation level is just less than the NSL. it means cutting again. The cutting will start actually somewhere from the middle of station 90, okay, and station 120. So here, okay, on this side we have actually cutting maybe, and on this side we have actually filling. So in the same example, we are facing cutting and filling at the same time, okay? And this point where we actually, let me just draw the map, let's say, okay? If we have this thing, such as this one, okay? Let's say, just a minute. If I can just remove this line, and let's say if we have the formation level, okay, well here we have the formation level above the NSL, but at the at the end, as you can see, the formation level is just down, or you can say below the NSL. Okay, the green one that represents NSL. Okay, this one, and this guy represents the FRL, or maybe formation level. Very simple, okay? It means we're here, we should have filling. This portion is just filling, and this portion that is just, you can say, cutting. Very simple and straightforward. But here is a point, this point, where we don't have cutting and filling as well, okay? Their cutting and filling both are just zero. This point is just actually known by the intermediate point, okay? IP, intermediate point. Intermediate point is actually a point where we don't see any cutting and filling, you can say, okay? Or you can say the FRL is just crossing NSL, or maybe NSL is just crossing FRL. The things are actually a little bit different. So let's just move ahead to the calculation. And in the calculation, let me just have the same table. And here the section for cutting portion, okay, where the side slope is different. And the section for filling portion where side slope is just different, which is 2:1, okay? Very simple. Okay, so we have RDs, which is 0, 30, 60, 90, 120, 150. Okay, I have left this cell, okay, blank because I already know that there is intermediate point. Then we have NSLs. Remember, these things were known, okay, NSLs. In the formation levels, these were also known previously if you just saw it, okay? Now we have to determine the depths at each interval. And for that, we will subtract NSL from FRL, okay? Very simple. Like maybe you can say 252, which is the FRL of station 0. We will just take that and we will just subtract the NSL, okay, which is 251. And that's going to be the depth, which is actually 1 meter. And again, 251.8 minus 250.9, that's going to be 0.9. Okay, and so on. Just do that. So this is the same process. We're here, as you can see, when we subtract 250.8, or you can say when we subtract 251.2 from 250.8, that's going to be minus 0.40. And that indicates that there is actually cutting, okay? That minus sign represents the same thing. And again, minus sign for 150 station, it means cutting again. Now we will just determine the mean depth, and if you remember, mean depth means just to add 2 stations at the, you can say the depths of 2 stations, and then we will divide that by 2 so we can have mean depth, okay? So just add those 2 stations depth and divide that by 2 so we can have the mean depth for station 30. And again, 0.9 plus 0.7 divided by 2, that's going to be 0.8. And then again, 0.7 plus 0.6, that's going to be 0.62. Now, one thing which is very tricky and you can say technical word here is actually the intermediate point. How do we locate the intermediate point and what should be the station? I mean, intermediate point is somewhere between 90 and 120 station. But where is it? Is it at station, you can say 95, or is it at station 110? Okay, we exactly don't know the location for that. That's why it's very important to calculate the location of intermediate point first, and then we can move ahead, okay? So as you can see, let's just represent that graphically so you can understand it better more. Let's say this green line is actually the formation level, and you can see the NSL, okay? Now here, these points which are circled, they are just known by the intermediate point, because there we have actually no cutting, there we have actually no filling, okay? Let's say, as you can see, we're here, this is actually just filling. You have to fill here, okay? In these places, you can say these red shaded should be just cut out, okay? These are actually cutting. And for the black one, these are actually filling. So this is actually the formation level. Now next, as you can see, we have the intermediate point and that should be determined. And how do we determine that? Okay, for that, the distance, which is intermediate point, should be actually the uh, depth at lost station, which is station 90. And we will actually divide that by the same depth, okay, which is the depth at station 90. Okay, and we will just add the next depth, which is actually 0.4, and then we will multiply that with the interval, and actually we will just add the last station, okay? And this is going to give me the intermediate point, which is 108. That means the station, which is 108, the cut and fill over there are just 0. Okay, this is very simple and straightforward. We don't have NSL over there, we don't have FRL over there because we are not calculating that. They are not needed. And the depth over there is 0. And 0 depth means that no cutting, no filling over there. Okay. So once we have actually the intermediate point, then of course we can calculate the mean depth for station 180 and station 90. Okay. And that's gonna be 0.3. Again, the mean depth for station 108 and 120, that should be actually minus 0.2 and so on. Okay. Once we have the mean depth, then of course we can calculate the sides areas, or maybe the central one as well. Okay. And that is
Sir, repeat the distance of intermediate point.
okay, just let me just go a little bit back so you guys can understand it. Okay, the intermediate point distance, there should be actually the depth of lost station, which is actually the depth of station at 90, and that is 0.6. We will just divide that by the same depth, and then we will add the next depth, which is actually the depth of station 120, and that is actually 0.40. We are not just actually including that minus sign because we are looking at the depth only. And this is the same thing as similarity of triangle, okay? The same way as we determine actually the point of counterflexure. If you're a little bit familiar with these, maybe structure analysis. And then we will actually multiply this with the interval, or maybe the distance between two stations. And that is actually the distance between station 90 and 120. So it's just 30, okay? And then we will add the last station. Why we are adding last station? Because if you don't add last station, then of course that's gonna give me the distance. This formula is gonna give me the distance from 90 onward. Okay, we are adding the distance up to 90 because we are calculating the intermediate point from point 0. Do some math so you can have actually the intermediate point. Is it clear now? All right, so BD, that's actually the central area, and that's very straightforward, okay? P is already known, which is 10, and that should be actually the depth, which is 0.9. So 10 times 0.9, that's gonna be 9.5. And again, for station 60, 10 times 0.8, that's gonna be 8. 10 times 0.65, that's gonna be 6.5. 0.3 times 10, that's gonna be 3 only. And minus 0.2 times 10, that's gonna be actually minus 2 and minus 6 again. Now SD square, okay? SD square. For S, we're gonna put 1 or maybe 2 because we have cutting and filling both, okay? And over here, as you can see, we have cutting. So for these portions, we will just include the side slope for cutting, which is actually 1. Okay. And for the above portion, we will just include the side slope for filling, which is actually 2. In the previous example, actually, it was just the same thing. Okay, one side slope for both. Because over there we had actually only filling. Okay, this time we have both things, cut and fill. Okay, so for station 30, SD square by S, we will just put the side slope of the section which is in filling. Okay, and we will just multiply that with the mean depth, and we will have actually square. So simple, and that's gonna be 1.8. How 1.8? Again, let me just repeat it. We have actually SD square. So put 2 for S, and then D, that is actually 0.95, and take it square, and that's gonna be actually 1.8 square meter. Is it clear? It's just straightforward and very simple mathematics. Okay. You can also do this thing in Excel. In Excel, that takes very less time, and I actually share those Excel file, which I have already made, and videos are already uploaded, okay, on the same channel, Engineer Boy Official. Okay, for next station, we have actually the mean depth, and then the side slope again the same, and the area should be 1.28, and so on. However, after the intermediate point, we have actually cutting. Then, of course, we will just use the side slope from the section which is in cutting. Okay, and that's actually 1. So the area should be 0.04, and for the last station, the area should be actually 0.36. Now, summation of area means just to add those two areas, we can have actually summation of area. Okay, and I'm going to do that very quickly. Interval is just known, which is 30 meters. Now, area times the interval, that actually means the quantity. Okay, and that's going to be actually in cubic meter for cut and fill both. So that's 339 cubic meter. Okay, up to station 30. And then we have actually for the other station, which is 278. Again, we have 220. And then we have actually 57. But after this, as you can see, up to 108, which is station this guy, and the quantity is 57. Over here, we have actually all these things, these are in filling. Okay. After this, we have actually cutting, which should be just the area times the length, which is 12 meters. And here is one trick, okay? Because 90 and 108, actually, this is 108. We will subtract 90, so it becomes 18, okay? And that's actually the interval. And after 8, up to, you can say, 120, that should be then 12 meters. So 12 meters times 2.04, that should be 24. And next, again, we have 30 meters again, and the area is 6.36. So if we multiply that, we're going to have 190.8 cubic meter is the cutting. Very simple and straightforward. If there is any question, you guys can ask them.
सर ये 108 आरडी पर 57.24 कैसे आया है? ये तो इसमें न कटिंग है न फिलिंग है, तो किस तरह?
अच्छा, सवाल दोबारा पूछे, क्या पूछा आपने? 108 पे क्या?
108 आरडी पर ये 57.24 क्वांटिटी किस तरह? ये
वेरी गुड,
इसमें
वेरी
न
गुड।
कटिंग है न फिलिंग है।
एग्जैक्टली यही तो पॉइंट है। देखे, 108 पे हमारे पास ये 57.24, ये जो फिलिंग है ये एग्जैक्टली उस पॉइंट पे नहीं है। ये तो असल में स्टेशन 90 और स्टेशन 180 के दरमियान जो जो डिस्टेंस आ रहा है ना, 18 मीटर का डिस्टेंस है भाई। तो 18 मीटर में इतने क्यूबिक मीटर का फिलिंग होगा ना।
जी जी सर।
तो सॉल्व हो गया आपका क्वेश्चन।
जी जी साल हो गया। और ये फिर 108 से 120 तक ही फिर कटिंग होगी 24।
एग्जैक्टली क्योंकि इंटरमीडिएट पॉइंट के बाद कटिंग आ रहा है।
जी जी सर।
अल्लाह हाफिज।